Good afternoon, everybody. My name is Andrus Adamchik, and we'll be talking today about a certain idea of how to write REST services, a certain philosophy, and a technology that actually implements this philosophy. First, a few words about myself. I'm Andrus Adamchik. I am an open source developer. And as you see from my GitHub history, I spend much more time writing code than actually talking about it. But right now we'll do both, I guess. And whatever you hear from me about shortcomings of REST, I'd like to start, I'd like to have a disclaimer. I love REST. So that's my favorite architecture for implementing web services, of course, and implementing any kind of services, really. It is based on a clean HTTP protocol, and that is proven to scale to really like infinite number of users, machines, and whatnot. So it's really a good idea, if you're considering a service to use REST. There's so many benefits that it's just beyond discussion. However, just like with anything, there are little snags here and there, and sometimes it feels, especially if you're writing a client to consume web REST services, sometimes it feels like you're trying to put this square pin in a round hole. And what I mean by that, okay, let's take an example that many of you will probably understand. We have a domain model, say, of GitHub centered on issue. So GitHub has many submodels, and let's take a look at how GitHub issues operate, how the REST services are built by GitHub engineers to access issues. And usually, the way people approach it, they break a domain model, they break it into certain aggregates. So they draw this arbitrary, well, maybe not arbitrary, but they draw these boundaries around entities and group them together and say, okay, issue, milestone, and user is one aggregate, and like comment and whatever entities are related to comments is another, and event is another, and repository is yet another, right? And this is how GitHub API is organized. So this is an aggregate-centric REST API approach. This is classic. This is how most people are doing, especially public APIs. And usually, you create a single REST resource per aggregate, right? And this helps with decoupling and encapsulating parts of your model. And I guess the goal is to simplify the evolution of different parts and versioning of the API and everything. So essentially, aggregate-centric API is designed for server-side developers to allow to implement all the constraints that they want to implement. So they don't want the clients to go crazy. They want to control the API. And of course, one of the assumptions is that the normal use case is you never cross the aggregate boundaries, so you take the whole aggregate and do whatever you want with it, and if you need to cross the boundaries, there are certain ways of achieving that. This causes two problems that were illustrated a few slides back with the square peg and the round hole. The first one is you get too much data from such an API. So I took some measurements just trying to get the issues of LinkRest project a couple of days ago, and I'm getting something like 126K JSON. I mean, it's not too big until you actually, if your interface, if something that you're building on the client only needs these three fields, like title, number, and ID, you really only need 3K. So 123K, they were generated by the server, they were transferred across the wire, and then they were parsed in the browser or whatever, and then it was thrown away. So it's a total waste, and it adds up, and it makes your interface slower. You pay, as a service owner, you pay more for bandwidth and server CPU cycles. The second problem is too little data, and this is what I was talking about, like crossing the aggregate boundaries. So what if, in addition to issues, I also need events? There's no events in the issue aggregate. So it's a separate submodel. It's a separate aggregate. So what you usually do is, you load the issues, and then you go parse that JSON and find some hypermedia controls. You find a hyperlink to all the events of a certain issue. And this quickly becomes an ON problem, right? So you need to make 1 plus n calls to resolve issues resolve events for each one of the issues. And you can see how it can devolve very quickly, and just it won't perform. So you may need to just get rid of this idea, redesign your interface or whatever, or resort to some tricks. So in LinkRest, when we designed LinkRest is an open source project. And when we designed it, we looked at these problems from the client person perspective. Even though I'm a server-side developer, I write everything in Java, and we decided to address that. So essentially, we thought, like, why do we need to break everything into aggregates? Can we just expose the entire model, of course, with certain constraints, and allow the client to decide which part of your graph they want at any particular moment? And you can have, if you are deploying public APIs, you can have different clients, and they have their own ideas of what's important, what needs to be shown on at any given moment on screen or something like that. So the client decides on request shape and size, and you just give them the entire graph and like some entry points into this graph, some like entities that they may want to fetch first. And we wanted to get rid of this notion that one size fits all. This is a traditional notion in REST API design, and we try to challenge that, essentially. And the last point is kind of an implementation detail, but we also wanted it to be easy to use, of course. And the first idea was that we already spent some time in our project or whatever to design an ORM model. So why don't we just take this ORM model and make it the basis of the model of this REST service of our graph, right? The ORM model is a graph. So our REST service, can take this graph and use it. But this was the first step, and of course, LinkRest supports non-ORM models as well, and I will show it in a demo. Well, before we go to the demos, I just want to mention that the ORM in question here, so the ORM built into LinkRest, or rather used by LinkRest by default, is Apache Cayenne. That's also one of my open source projects. I did a talk on this last year here, and it just works out of the box. But if you want to switch to JPAs or mechanisms, you can create an extension. Anyways, let's actually try to write some code, and everything will be here. Everything will be about hockey, because National Hockey League, they are the collaborators on this project, and they're a good client of ours. So we work on this together, and even if you don't care about hockey, you will understand the model, right? So the championship is just a list of games, and each game contains 2 teams that are playing between each other. So we have a game table and a team table, and our first task will be to build a hockey schedule. So the schedule is a sorted list of games with teams. So let me go to the IDE. I already have a shell of a project, so I didn't want to spend time showing you how Cayenne works and everything. So, but it's just reverse engineering. So I have a database schema. So I spent like a total of, I don't know, maybe 5-10 minutes to build this model in Cayenne. I took a database schema, reverse engineered it, and that's it. Also, the application will be running using Boutique, not Spring Boot. So that's yet another open source project that was shown last year at this conference. But again, it's not about Boutique, and you can use LinkRest without Boutique. It just helps us to start the application. So it's a standalone Java container, which in my opinion is better than Spring Boot. But that's beyond the point here. So here I have a simple JAX-RS API class. Here, right now it's empty, it doesn't do anything. So it's standard JAX-RS. It is not aware of Boutique, Cayenne, or anything. To build the schedule resource, I do the normal JAX-RS thing. So I create a get method that returns some data. And in LinkRest, you wrap this data in an object called data response. So it's kind of like a list with some extra properties. So we do get. So we call our method get. We annotate it with get. Now we need to hook up to LinkRest somehow, so we need to get a hold of it. And to do that, we we do it also the way JAX-RS does it. So we use JAX-RS annotation, injection with context annotation, and we inject JAX-RS configuration. So that's the easiest way. It's really independent of any environment. It just has to be a JAX-RS. And we also need to inject the URL information of the request. So another JAX-RS thing, URI info. So we got that, and now we can write our LinkRest code. Okay, let me hide this part. Okay, so LinkRest starts with the word LinkRest, so it's really easy to remember. And now we have a bunch of operations. We're interested in select operation because that's a get method. It returns the data. Here we specify the type. We specify configuration so that it knows where to find the runtime. We bind the URI, and we do get. So that's it. I mean, this is, well, I wanted to call it one-liner. It's three-liner in this in this style, but it's really like a simple chain of calls that gives us a service. Sorry. So now I can go to the main class. It's a boutique main class, and run it. And if everything is well, it should work. So boutique tells me what URL it is on. Okay, so I already got something. So it's not even an aggregate, it's just a list of single entity. It's a list of games, right? And it's a pretty big list because it shows all the games in the database, really. And the first thing we're going to do, so now I'm going to show you how we implement that promise of accessing the graph and letting the client to shape up the response. So the first thing we need to do is probably create a limit so that we don't display the entire database. There's a key in the URL called limit. So I do limit 3. You see I got just 3 games, and I get the total. So essentially the client is aware of how many objects are there. So that's the first control for pagination. I will show more, more details on pagination shortly. And I only got 3 objects in whatever order, so database returned them. The next thing I can do, what's missing in the schedule? The teams, right? So I'm only showing the games here, so I also need the teams. Game object has a method get home team and get visiting team, 2 methods actually. So those are properties, so I can reference these properties using the include key. So we do include, and we do home team, and we want its name. We don't want the entire team, we do its home team name. Okay, so you automatically got the related object, so we're already starting to traverse the graph. And let's do the same thing for the visiting team. Include, visiting team dot name. So here's our schedule, pretty much. So we can do other good things with it. First thing, let's sort it, because right now we have like 3 objects like out of, from the middle of the list somewhere. So we can add another key, which is unimaginatively called sort. And it's let's sort on date time, so it's in a calendar order. So now I have the first 3 games on the list, so it's really the ordered list. So now it starts to make sense, and we can also filter things. So let's, for instance, filter the games that are played in the United Center arena, and this is the home of Chicago Blackhawks. So it means that we will get the first 3 games played by Chicago Blackhawks. Well, just because that's their arena. And to filter, we use a special key called Cayenne exp. Even though it has Cayenne in it, has nothing to do with Cayenne. It's just, well, Cayenne provides a parser for it. So it's a certain certain format, certain grammar for creating object expressions. But it's really pretty simple. It just you will see it. So it's like arena equals United Center. So now I only see the United Center game, so it's the first 3 games of Chicago Blackhawks. Okay, so it was all pretty cool already, and I wrote those 3 lines of code, and now I can spend the entire day here like trying different things in the browser. So I already got like an engine that the client can play with, and so for instance, your client-side developers can use like a little prototype based on some database schema and start writing their interfaces while you go back and implement some business rules, for instance. But let me show you something. So a game has home team and visiting team, of course. Team also has a list of games, so it's also a property of team objects. I mean, that's how it's mapped. So I can actually do, I can keep traversing this relationship. So home team, and it has visiting games, so it's a two-man relationship, so it's in plural. So I have a home team and a bunch of games in it. And it's a lot of games per team. Of course, each game has a team, right? So it has home team and visiting team. So I can do home team again. All right. And that has visiting games. OK, so this takes a while to render, right? So it can get worse. I mean, I can keep doing that. So as you see, so if you have a graph that's completely open, and especially if it's connected in both directions, if it's not a unidirectional graph, it's really very easy to break your app and totally DDoS it, and just make sure it doesn't work for anybody. How do we deal with it? So it was very easy to start because we already had a model, but now we need to define constraints on this model. And in LinkRest, this object that helps us is actually called constraint. So we have a class called constraint builder. So let's actually disconnect those relationships, or rather disallow to reference relationships from teams to games. So we do a team. It's a team constraint. And I have various options, ID and attributes. So we only allow the attributes, but not the relationships of the team. So let's do the same thing for games. So because we are working with games, GC calls constraint. Oops. Constraint ID and attributes, and it's a game. OK, it's not enough, so we need to attach team to the games, and we do this because it's a there's a relationship. So we define that we allow this relationship from game to team, but that relationship will be constrained by the team constraint. So we do home team TC, and then we do visiting team TC. And now I add this constraint, the game constraint, I add this to the chain. So it's a GC here, and it was pretty simple. Let us go and restart the app. OK, the app restarted quickly, and I reload this horrible thing. And you see, so everything that is not allowed is just not shown. I mean, I stripped all those properties that are no longer there in our model for this endpoint. So I can go back to our normal like home team.name, and it still works because we allow the attributes, but we're not allowed to traverse these relationships anymore. OK, so let me go back to the slides. So the things that I did in the browser we call LinkRest Protocol. So the protocol means that we actually fix those keys, and the client can rely on those keys, even though we can swap the backend, for instance. We can start with Cayenne, but then switch to something custom. And let me go quickly through the keys. So the first one was include. And you can include just one attribute or an ID attribute. You can include multiple things, right? Including the relationships, so you can traverse your graph. There's also an exclude key. It's just a convenience. If you have like a big entity and you want to exclude just a few things, but includes the rest of it, you can use exclude. Filtering was done with Cayenne exp, and I told you it's not specific to Cayenne. It can be applied to anything. But in case of Cayenne, it will generate the SQL actually. So in case of Cayenne, it just works, and it provides it's bound to a specific backend. In addition to just a simple expression, you can use a JSON object there, or as a JSON array. And the first element in the array is the template for the expression, and the rest are positional arguments that will be bound to this template, right? And it will be, of course, also translated to SQL. Sorting is simple, right? So you can sort by property. You can specify the direction of sort, or you can provide also a JSON object and specify primary sorting, secondary sorting, and so on. the first thing we saw was like a limit key. So limit key is essentially one part of the pagination solution. So another part is a start key. So you can specify start. So you understand, like start is an offset. So if I have a list of 10 objects, so start creates an offset. Limit is how much after this offset, how many objects we need to include at the most. And when used together, they give us pagination. And the important piece is that you control start and limit, but LinkRest always returns total in the result. So you know how many objects are there without start and limit. So you can plan your interface. So you can create some scroll controls on a mobile device, or some kind of pagination navigator on desktop browser site. Because all this information is available, and you only see this small piece, but you know how many objects are there. There's also an advanced include that I haven't shown in the demo. It allows you to, so we went from games to teams. So now let's think about going from teams to games. It's a one-to-many relationship. So if we are fetching a list of teams, we know how to filter teams and order teams. But then each team has I don't know, dozens or maybe hundreds of games. We shouldn't be retrieving all of them at once, really. If we only need maybe just certain games that were played in a certain arena, or maybe we get in some statistics. So we're looking at some scores in those games. So we can filter at the second level. So when we originally applied Cayenne expression, we applied it to the main list. So you can apply it to every sub-list as well. So you can apply Cayenne expression for filtering, and you can apply sort for sorting. And the whole result won't fit with all the games. So I'm just showing home games and just showing the IDs of those games, and presumably they're filtered. So it's not 1,000 games in there. We saw constraints API, and the first goal is to prevent denial of service attacks, of course. But there's another goal, which is, I guess, much closer to the business value in your application. You can actually create a fine-grained attribute security. And the way it works, of course, is that you can, whatever authentication system you have, it's outside of LinkRest, but whatever you have, at this point, when you're inside your API call, you already know who the user is. You can check her permissions. So you can actually map those permissions to a set of constraints, and you can swap constraint objects depending on who came and who requested this object. This is how we implement applications, for instance, that have, I don't know, maybe a dozen roles and really dozens, maybe 100 permissions. So we create these constraints, and they filter what the user can see, what fields the user can see. Another demo, how do we actually change the data? So it was really neat how we navigated the graph and everything. So with modifying the data, I guess it's less flashy in the sense that we are editing one entity at a time. But the API for this is also very simple and very similar to what we already have. So in terms of REST, so what methods do we use to modify the data? So I guess there are two main methods, post and put, right? And I guess many of you know the difference. So the put is characterized by this weird word idempotent. So, and idempotent means that if you run it multiple times, the result is the same as if you only run it once. Right, so that's the difference between post and put. And let us write a put here. And I like put because it gives you some room for error. So you can submit the request multiple times, and it's not gonna insert two objects. It will just insert one, for instance. So it's the same data response game. So and we do put. So we would want to insert some games. And I can actually add a URI info too, because that shapes the result that we send back. And here I will do turn LinkRest. So the methods that I have here at my disposal, some of them start with idempotent. So this is why I mentioned that, because you will need to choose whether your update is idempotent or not. Ours is, because it's mapped to put, so we shouldn't be breaking HTTP conventions. And we do creator update. It's also add important creator update game. Okay, let me scroll up a little bit. Okay, configuration. We tie the URI. It looks pretty much the same. And at the end, we also have a few options. So we need to bind it to an object that contains the updating data. I will just use a string, but there are options to pass some objects, explicit update objects, so you can interfere and maybe like build them manually or something. Let me add this string here. String, it will be update, so it's a payload of our method. I will show you what it is. Okay, so now we restart. And since I cannot send a put request from the browser, I have it here in this Coca REST client. So here is a new game that I want to insert. And it has a new ID and everything, so it doesn't conflict with any existing games in the database. So I just submit it. And I can go back to the browser, and I will need a special sorting to see it, because it goes to the end of the list. So it's a new game with a newer date. So let's sort by date time in descending order. Date time, descending, and here's our game. So it's a 231. So yeah, it was 231. So this game got inserted. So if I keep submitting it, it will work, of course, but nothing will happen to our data. It's idempotent. So it's only that same game. Now if I want to change the game, so I need to change the request. So if I want to change the date time, I will need to run this request with a new time. And obviously when I run it, the time will change. So it was like 16:00 UTC. When I do reload, it's 17:00 UTC. So I bumped the time 1 hour. And again, if I keep rerunning this guy, of course nothing will change. So it will just keep updating the same object, and with the result that nothing gets saved to the database. Okay, so this was updating. This is update flavors, and as you see, so the ones that start with idempotent, they're appropriate for put methods. The rest are appropriate for post method, because they will create a new object every time. Except, of course, the one in the bottom, which is a delete, and it's a separate HTTP method, delete, right? Okay, so now I'm at a point where I want to fetch some custom objects. I have consider a live game. So hockey games they're really dynamic. So lots of things happen. Like every second, something happens. So somebody gets hit or whatever. So or somebody shoots and maybe scores and stuff like that. So all these things arrive to our system as events. So an event happens, so we receive this event, and maybe our system, for whatever reason, doesn't want to save them in database. Maybe there's just too many of them, and relational database can't load, can't handle this load or whatever. So they arrive, say, from some messaging system, and we would like to build a REST service that displays these events. And in this case, I cannot use standard LinkRest, standard backend. So I will build a custom backend. And I have another project here called LR event. It's also a shell of a project, so it's really empty inside. Let me copy some code from there to event API. So the endpoint on in this app. Okay, and I'll need to remove all the irrelevant stuff and replace our game with an event object. We'll look at this object in a moment. So here's an event object. It's not tied to Cayenne. It's not persistent. It's just an object, right? The first thing you notice, all the attributes that I want in my model, they are annotated with LR attribute. So that's a special annotation that tells LinkRest that, okay, so we don't have a model, but let's build this model on the fly by looking at the objects, and only the properties that are annotated are included as public LinkRest properties. And there's also LR relationship. So it allows us to build the entire tree of objects, right? How do we get the events? So we have an event DO service. So that's our custom backend, essentially. And in my case, I don't have a messaging system here, so I just created this random event DO thing that just takes some games and generates random events like that have nothing to do with real life games. So I have this service. How do I use it in LinkRest? There's an API, there's a listener API in LinkRest. So essentially, LinkRest calls are chains. So that they are essentially just the sequences of steps. And between each step, I mean, those are well-defined steps. Between each step, you can insert your own processor, a listener, that can intercept it, do something with the data, and maybe like even cancel the rest of the chain. And we're gonna do this exact thing here. And the listener is, I also have an example here. So here's an event listener. So the method, the event method is written, following a certain pattern. This annotation tells us where in the chain to call it, and we pass a context to it that integrates, essentially tells us what's going on in LinkRest. And we return null, meaning that we want to cancel the chain. So this is the last step. Once we get the data, LinkRest should no longer attempt to get the data again, for instance. Now we need to go to event API and add this listener in here. But first we need to get a hold of our event DO. And it's injectable via boutique. And here we create a listener. New event listener. Okay, of course this can be cached. You don't have to create it every time. It's just here I'm showing it for simplicity. It has its own main method. This is a new microservice. So I locate this main method and run it. Let's see if we can watch the events. Okay, so it generates some events. So it's 5 events right now, and I reload, it's 10 events. So it just adds 5 events every time I reload. So that's a dummy backend, really. And I can use the same keys. I can do limit, right? I can do include. What do I want to include? Type. So I can do these things, but I cannot do some other things. So for instance, if I want to fetch just the goal, so one of the event types is goal. So I have goals, shorts, and penalties. So if I do kn_exp equals type equals goal, nothing happens. I mean, it still shows their own objects. It means that certain keys will not work, in our simple backend. So we need to go to our backend and actually make it work. So LinkRest delegates to your backend to handle these keys. And for this, let me actually copy paste a piece of code. Okay, we need to go to the listener, the event listener. So we got the events, and now we can filter them in memory. So this is what I was talking about when I said that Cayenne expression can be used to filter non-Cayenne objects. So I have this qualifier object, which is a parsed Cayenne expression. It's already in the context, in LinkRest context. So I can take it, and I can filter the objects. So it's applied already after the objects are fetched. Of course, this is not very efficient because you still need everything in memory, and then you filter in memory. If you wanted to make it more efficient, just write a backend that recognizes it from the start before calling any services. Here essentially we can restart and see if this worked. All right, so there's no goals yet, so the events will arrive eventually. Somebody scores, somebody scores, somebody scored. So now we have like 5 goals and 6 goals, 11 goals. So okay, so the filter is working because we added it to our custom backend. So the takeaway from this is that any POJO can be annotated and exposed in LinkRest, but you are responsible to provide a backend, to provide a data source for where these objects come from, and it depends on you how efficient it will be with all those protocol features and certain things LinkRest will do for you out of the box for these objects, like include, exclude, limit, and stuff. But the rest of the features, you're responsible for them, and even those, even like include, exclude, you should probably take them into account. Like you don't want to fetch your entire database in memory and just to let LinkRest filter a couple of attributes, right? But this information is available, so we make it easy for you to write it. Another demo here, I would like to marry the two services that we had. So we had like a schedule service, right, and an event service. And very often on sports sites, they have something called a header scoreboard. So on top of the site, on top of the page, you will see a list of recent games. So the games that are being played or will be played shortly, and you will see their scores. If a game is in progress, the score will be updating all the time, right? So how do we do it if we have the two services that we already have, right? So we need to combine them somehow. And I will do this aggregation. I'll let the event service run because we will need it. But the source of it will be the schedule service. So we go back to our schedule API, and we create another method. So I'm going to steal from here. Okay, so I have another endpoint essentially called Scoreboard, and it's no longer a simple LinkRest. So it's a LinkRest wrapped in an aggregator, and it's called LinkRest multi-source. And I start with a simple LinkRest. That's our root. So that's the same thing as before. But then I add another parallel fetcher. So I add a call to fetch from our event service, and I provide two functions: one that fetches the score, and another one that merges the score into games. So essentially, we'll see what score is in a moment, but let me dwell on this for a moment. So essentially what it does, it starts two things in parallel. It goes to the database to execute LinkRest. So that's one parallel execution, and another parallel execution is this guy. So it fetches the scores using the remote service. So it will do like an HTTP call. And once both are ready, this function is invoked to merge them together. So internally, it's just regular Java completable features. So Java 8 has nice API for this type of processors. So the score is our POJO with annotation. So essentially, it doesn't have a database backend, and the fetch scores does JAX-RS client, and we have a LinkRest client to help you assemble the query. So it does this cayenne expression equals goal, type equals goal, and it gets all the events filtered by, it just gets the goal events, and then it just parses the JSON, creating those score objects. So that code is not that interesting. And the merge scores attaches the scores to games. So let's look at the game object. So game object has a score property, but it's not persistent. So game itself is persistent, so it's managed by Cayenne. But this property is just a regular property that you can set and get, and this is what we're doing with this. Now going to schedule main. Let me run this guy. And let me go back to our schedule, and we need to hit a different resource, Scoreboard. Okay, I reloaded. It looks exactly the same as before, right? But because I didn't include the score yet. And first, before I include the score, let me change the sorting, because our event service updates only a subset of games, not all the games. We need to merge those games. So these games are being updated. And now I can do include score. I got the score. And now if I keep refreshing it, so that's your structure to build this header scoreboard, and JavaScript can do it without any data processing. I mean, they just need to build this call. And if I keep reloading, eventually somebody scores and the score will increase. So now I have 2-2, it was 1-2. Okay, now I have 3-2, somebody else scored. All right. So this was about aggregation, and I made it sound simple, but it's really not simple. And the problem itself is also an ON problem that I showed before, right? So, but it's taken from the client, it's taken to the server, and then server-side developers decide how to do this aggregation. But I guess the point is that if you publish a public service, right, public API, you would want to keep that API stable and change as little as possible. So it just takes this burden to the server, and if some backend changes, you can swap it on the server, but the client will not be aware. And then you need to figure out how to optimize it and how to avoid this ON problem, maybe by caching something or whatever. So on the server you have all these tools. At the end, I want to mention this little thing. So how many of you are aware of GraphQL? How many of you know GraphQL? All right. So essentially, LinkRest predates GraphQL, and when Facebook this is a product of by Facebook that essentially follows the same philosophy. So it's really the idea that you shouldn't be forcing the client-side developers to go and look for different aggregates and then deal with all this data on the client. But it was implemented differently, and Facebook announced it. What was it, like a couple of years ago, to great fanfare, and essentially it's a good idea. It's the same type of idea. So this is why I'm saying great minds think alike. But in the implementation is of course very different. For us, we were kind of excited when GraphQL got released, because this was a good argument for LinkRest as well. So it's sort of, they publicized our idea to this wider community, essentially. But the implementation there is different. So GraphQL is not RESTful. They're using HTTP as just a transport. They're not using it as a protocol. They don't take advantage of HTTP. So GraphQL is this idea where you create a schema. So this whole language of creating JSON-like schemas, but not really JSON. And you create a schema on the server, and then on the client you can call a subset of that schema. And you can also specify, how big or how small your response is, which is exactly what I've shown. So it's our model plus constraints. Of course, the difference with in LinkRest is that it is still REST, even though it may not be classical approach that everybody does. It's not aggregates, but it's really REST. It's really easy to build a client. This is where I'm getting at. So if you are a JavaScript shop, you can create the servers and get it running in no time. And another thing is that it's also an implementation. It's not just a protocol idea. It's also an idea of a server that already works with the most common data store, with relational database, and that then you can plug in alternative backends. So we are close to, between us and GraphQL are close, but we are different enough, to consider it as two separate products, and not just competing with each other directly. So LinkRest is an open source project, like I said. It's running under Apache. It's distributed under Apache license. Site is LinkRest.io, and please go to GitHub and check it out. And we have some pretty good documentation. It's always a challenge to keep it up to date, but we're trying, right? And it works well with other open source projects that I mentioned, like Boutique and Cayenne, but it doesn't have to. You can integrate it in your own stack. So thanks for listening. I'll take questions. Okay, any questions? No? All right, I'll be available over there. Thank you.